And welcome to this last tutorial. In the final tutorial, we will be able to list, recognize, and use the three power reducer identities. So if you flip on over to this page of our notes, we have our final three identities, and these are the power reducer identities, or power reducing. Sometimes it's not helpful to have the sign squared, and we want to reduce this power. We're not going to replace it with 1 minus cosine squared. That's one of the Pythagoreans, and it doesn't reduce the power. The sine squared power reducer is equal to 1 minus the cosine of 2 theta divided by 2. So, yeah, well, what it does for us is it does reduce our power. It goes from squared to the first power, but unfortunately in doing so, it takes our single angle and makes it a double angle. So we would have to deal with the double angle identity. Okay, so that's what our sine squared is equal to. Cosine squared is equal to 1 plus cosine of double theta divided by 2. Same thing. We have reduced our power from squared to first, but we have doubled our angle, unfortunately, in doing so. The tangent squared, again, tangent is really just sine divided by cosine, so if you can almost imagine just dividing these two values, the 2's cancel away, and we have 1 minus the cosine of 2 theta divided by 1 plus the cosine of 2 theta. Please be careful with your 2's. Make sure that these are written as big coefficients. 2 times theta, they are not exponents. And these represent our final identities. And now we have all 39 identities. 39 total. Please add these to your flashcards and put them into the rotation. They're not used as often, at least at the pre-calculus level, but they're still ones that I would have you memorize. And we're going to do one final problem with our power reducers and some other things. And here's the situation. We want to rewrite sine to the fourth of x as the sum of first powers, meaning we need to get all the way down to the first power, of cosines, and they can be of multiple angles. So it's okay if our angles start to multiply and become 2x, 3x, 4x, 5x, whatever, as long as our fourth power is reduced all the way down to the first power. Okay, so sine to the fourth, the first thing we're actually going to do is we're going to rewrite that into sine squared times sine squared. That's probably the best place to start, sine squared times sine squared, because we have our power reducers that tell us what to do with the sine squared, and we can reduce these powers right now. Sine squared, if I replace that with its power reducer, becomes 1 minus cosine of 2 times the angle, so 2x over 2, and the other one will actually be the same thing, 1 minus cosine of 2x over 2. What we will need to do now is multiply these two expressions, these two fractions. So multiplying means we just multiply the numerators together. This is a binomial times a binomial, so of course we're going to FOIL. The first terms give me 1 times 1. The outer terms are negative cosine of 2x. The inner terms are another negative cosine of 2x, which makes 2 cosine of 2x, negative 2 cosine of 2x. And my final terms, negative cosine of 2x times negative cosine of 2x becomes positive cosine squared of 2x. And that's all divided by, well, 2 times 2 is 4. So unfortunately, in that one step, we got close, but we still have an exponent here. So we still need to reduce this power. And it's okay because we have a power reducer which says what to do with this. But I am going to do one thing at this point to make it maybe a little bit easier. This denominator, I'm actually going to factor the denominator out. I'll just factor a 1 out of all the stuff in the numerator, but I'm going to factor a 4 out of the denominator. So basically, I'm going to pull out a 1/4. And I'm going to be left with the stuff in the numerator. I feel like it's a little bit easier to deal with this like this because I'm about to replace the cosine squared with a fraction. And instead of giving myself a complex fraction, I'll deal with this fraction at the end of my work and just multiply the 1/4 back in when I get there. So the next thing I'm going to do is reduce this power because, again, the directions say everything has to be of first powers. So I'm going to reduce this. Let's rewrite what we've got. We've got a 1 minus the 2 cosine of 2x plus. Okay, let's replace this. Cosine squared of 2x becomes 1 plus the cosine. Now remember, we're doubling the angle. Since the angle was 2x, now it doubles to become 4x. And that's all divided by 2. Watch out for that part. We're doubling the angle. That's what the power reducer does. It reduces the power but doubles the angle. So now we've got yet another fraction inside here, and if we want to try to combine all of this stuff together, which we do, we need to get that common denominator. Right now this term is over 1 and this term is over 1, and for it to have a common denominator, of course it needs a 2. So I'm going to multiply the denominator here by a 2 while doing that to the numerator. I'm going to multiply this denominator by a 2 while doing that to the numerator. Now let's see what we have. I'm going to come back up here. I still have that 1/4, and again, I'll deal with that in the end. 2 over 2, actually it's all going to be over 2, so if you don't mind, I'm just going to do one big fraction over 2. The numerator is going to be 2 times 1. Here we've got negative 4 cosine of 2x. And here we've got, well, this numerator doesn't change, so it's still just plus 1 plus cosine of 4x. Okay, looking good so far. We just have 2 more steps. I do see a 2 and a 1 that can be combined together to make 3. Nothing else is changing except the 2 and the 1 making a 3. And lastly, now that I have finished, I'm going to multiply the 1/4 back in. 1 times all the numerator is not going to change anything in the numerator. But the 4 in the denominator is going to change. 4 times the 2, of course, is 8. And that's our final answer that follows all the rules. All the exponents are 1s, and I just have cosines, and they have multiple angles. I've got a 2x and I've got a 4x, but that's fine. Another good problem using our power reducers. Thanks for watching this. I'll see you in class. See ya.